Hi, I'm Janhavi.
And I'm Gayathri.
We are students of IIT Roorkee B.Tech Engineering Physics 3rd year.
We are going to study the characteristics of a pressure transducer. This is for our course Applied Instrumentation PHN310.
Yeah.
Since we are performing an experiment on measuring pressure, what is the device which comes to your mind as soon as we talk about measuring pressure? The one which comes to my mind is a barometer. What does a barometer do? Is it measures pressure using the height of the liquid column which is inside a capillary, and the liquid inside the column is usually mercury. The problem with such mechanical devices is that it involves a lot of human error like parallax errors, and also it takes up a lot of space and it cannot be used for digital applications.
Let's consider an example of a robotic arm. A robotic arm trying to pick up this mouse, for instance. If it applies too less of a pressure, the mouse slips out. However, if it applies too much pressure, the mouse will break. Hence, it needs to pick up the mouse safely with the accurate amount of pressure that it needs to be applied. Let's consider another situation of hydraulic braking, where the pressure of the brake fluid needs to be constantly measured. For this, we cannot rely on devices which need human intervention. Hence, we switch to an electrical system. We do this by using a pressure transducer. What is a transducer? Transducer converts one form of energy to another form of energy. In our case, we're converting mechanical energy, which is pressure, into electrical signal. This is done by using a strain gauge.
A typical strain gauge is made of a thin, long conductive strip which is attached in the form of parallel lines in a zigzag pattern, and it is supported by an insulated flexible backing.
This strain gauge is attached directly to a diaphragm. The change in pressure is experienced by the diaphragm and causes the strain gauge to either expand or contract. During expansion, the resistance increases. During contraction, the resistance decreases.
This change in resistance is measured as a voltage in the electrical circuitry. We'll see the exact circuit back in the lab. We are studying the characteristics of a pressure measurement transducer using the strainer kit, and also for the calibration purposes we are using a mechanical pressure measurement device. This has two dials, one for the reading in PSI and another for the reading in kg per centimeter square. Coming to this part contains a diaphragm wherein strain gauges are attached. These strain gauges are later connected to the electrical circuit, which will be explained later on. Here we have chosen a very particular arrangement of the strain gauges on the diaphragm. We have chosen 4 different strain gauges, 2 of which are attached near the center of the diaphragm and 2 of them are attached near the periphery of the diaphragm. Why this particular arrangement? Because towards the center, the expansion in the diaphragm is more. This leads to more change in the resistance. Towards the periphery, there is very less increase in the strain gauge resistance, and this is later connected to a Wheatstone bridge.
Let's dive into the electrical circuit and let's see how we get the electrical signal from the pressure gauge. So as we can see, the main elements here is the Wheatstone bridge. The output from the Wheatstone bridge goes to the instrumentation amplifier, and then we get an electrical signal which is shown here in kg per centimeter square. Alright, let's talk about every part individually. Starting with the Wheatstone bridge. This Wheatstone bridge is in full bridge configuration. This means that every arm is connected to a strain gauge. In this configuration, when, as we know the properties of Wheatstone bridge, in a balanced configuration, the output voltage of a Wheatstone bridge is 0. However, when pressure is applied on the strain gauges, what happens is that the resistance changes. Due to this resistance change, we get an unbalanced Wheatstone bridge. This unbalanced Wheatstone bridge results into an electrical signal. Moving on to the signal conditioning unit, that is the instrumentation amplifier. Now, what is an instrumentation amplifier? That is just a differential amplifier like op-amp. What it does, it takes small signal produced by the Wheatstone bridge, amplifies the signal, and then gives a tangible electrical signal that we can note down. Also, when the pressure gauge is at 0, what we do is that we adjust the electrical signal to 0 as well. This is just to make sure that we are getting exact readings for the corresponding pressure which is shown on the pressure gauge. Hence, the 0 adjust is set to 0 when pressure gauge is also at 0. about the overall accuracy of the experiment we just performed. The two major factors that determine the accuracy are linearity and hysteresis.
So as you can see, the results of the experiments which we have just performed is graphed out, and the graph is roughly linear. A linear response is very important because a linear response means for a consistent increase in the input pressure, there is a corresponding or proportional output signal. A nonlinear response can mean that there are some inaccuracies, and it makes it very difficult for us to interpret or even trust the data which is given by the transducer.
Now moving on to hysteresis. Hysteresis also plays a huge role in determining the overall accuracy. You might have noticed that when pressure is loaded and when pressure is released, there is a slight difference in the electrical output which is generated. This slight difference is called hysteresis. In pressure transducer, hysteresis occurs due to the diaphragm. When pressure is loaded onto the diaphragm, it acts accordingly. However, when pressure is released, the diaphragm doesn't spring back to its original shape directly. There is a time delay. Hence, there is a slight difference in the values obtained while decreasing the pressure. This leads to hysteresis. We hope this video helped you understand pressure measurement transducer and its working principle.
We also hope that you got to know how the experiment is performed and how to analyze the results.
Thanks for watching.